Hi everyone, we are continuing with triangle similarity today. We're specifically talking about how to prove that triangles are similar. So for our warm-up, go ahead and read this and then try to answer. So pause the video right now. Okay, so fortunately if we have physical triangles, it's really easy to compare their angles because you can just line them up and check them with that. Alternatively, you could check using a protractor, but if you had actual wooden triangles, then it would probably be easier just to overlay them. So going back to congruence, a quick review. The 5 ways that we prove congruence of triangles are ASA, so angle, side, angle, 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 side, side, angle, side, 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 and then hypotenuse, leg. Okay, now with similarity, we have really similar postulates that we can use, the first of which is our angle-angle postulate. So what we say is that if two angles of a triangle are congruent to two angles of another triangle, then the triangles must be similar. So in this example here, let's say that angle X is congruent to angle L and angle A is congruent to angle P, then that must mean that triangle XAM is similar to triangle LPB. Okay, now we call this the AA similarity postulate instead of the AAA because the third angle must be congruent. So if two angles of a triangle are congruent, then the third must be congruent. Okay, now in terms of why there's not an ASA similarity or an AAS similarity, it's because we already have our two angles here, and so these both fall under the category of just angle-angle similarity. In terms of a counterexample for quadrilaterals, super simple, just consider a parallelogram and a trapezoid. So if we have a right trapezoid versus, let's say, a rectangle, obviously these two quadrilaterals have two angles that are congruent, but the third and fourth angles are not. So I cannot say that these two quadrilaterals are similar. Okay, so a few more postulates. Here we have the SSS similarity postulate, so very similar to how we prove congruence, except what we're saying is that if the three sides of a triangle are proportional to one another, then the two triangles are similar. So in this case, if AX corresponds with PL, and let's say AM corresponds with PB, and then if XM corresponds with LB, then I can say that these triangles are similar. Okay, similarly, we have the side angle side similarity postulate. So kind of same thing. If we have two sides that are in proportion to one another between two different triangles and they have a congruent angle in between those two similar sides, okay, those corresponding sides, the angle must be in between them, then we can say that those triangles are also similar. So in this case, let's say angle A and angle P are congruent. Let's say XA and LP are in ratio, and then let's say AM and PB also are in ratio, so we can form a proportion. So if, let's say, right over here, XA over LP is equal to AM over PB, and the measure of angle A is equal to the measure of angle P, or you could say angle A is congruent to angle P, then these triangles, XAM and LPB, must be similar. Okay, let's go through a few examples. So for our first example, we have two right triangles here. They tell us that this angle is 39. They tell us that this angle here is 51. We could name these. Let's go ahead and name this. I'll start at the right angle. So A, B, C, and D, E, F. Okay. So what would help is if I knew the measure of the third angle. So I can calculate that, obviously, and we end up getting 39. Okay, so I see that angles B and E are congruent, which means that C and F must be congruent, but it doesn't matter because I know angle A and D are both right. So by AA, I can say that triangle ABC is similar to triangle DEF. Okay, moving on, I have a triangle within a triangle, and I have two parallel lines. So by corresponding angles, I know that B and C are going to be congruent. E and D are also going to be congruent. Obviously, they share measure of angle A, but that doesn't matter because, again, we only need two. So again, by angle similarity, we can say that triangle ABE is similar to triangle ACD. Okay, so moving on, I have, again, two triangles here, and they have vertical angles this time. So I would know that angle WXB is congruent to angle UXT. Okay, now the only question is if their sides are proportional. So it looks like TX and VX are related, so I'm going to write them in ratio. So 12 to 16 must be as 15 is to 20. Okay, now all I need out of this is a true statement. So there's a few ways that you can verify this. You can cross multiply and see if you get a true statement. Alternatively, you can also just reduce the fraction on both sides. So if I reduce the fraction here, I end up getting 3/4. If I reduce the fraction here, I end up getting 3/4. This is true. So that means by side angle side, I can say confidently that triangle TXU is similar to triangle VXW. Okay. Now on example D, obviously 30/70, 20/80. Okay, so these angles have nothing to do with each other, so this is not similar. Alright, on example E, I have two isosceles triangles, and their measures are given. So again, I just need to create a proportion and see if they match. So I need to check that 6 is to 8 as 6 is to 8 as 9 is to 12. Okay, I see that this is true. Okay, so all of these proportions reduce to 3/4. And so by side similarity, I can say that triangle ABC is similar to triangle FEG. You could also do EFG, it doesn't really matter here because they're isosceles. Okay, last three before we move on to some proofs. So again, I have a triangle within a triangle here. So important to note that the total length of AC is 16 and the total length of AE is 12. So those are the ratios that I'm going to be using. 8 to 16 and then 6 to 12. So obviously I see that there's a proportion of 1/2 there. It's going to be true, so I kind of see the by side angle side. This is going to work out, but just to write out my work, 8 must be to 16 as 6 is to 12. And then obviously LAW is going to be congruent to CAE because they're both right angles, they're the same angle, so the reflexive property works there. And so I can say by side angle side similarity that triangle LAW is similar to triangle CAE. Okay, another example here of vertical angles. So I see angle XYZ is congruent to angle MNZ. And I have vertical angles here. So again, by angle, I can say that triangle XYZ is similar to triangle MNZ. Okay, last example here. I have two isosceles triangles again, so that means this angle must be 68. And the question is if this matches. Well, it does not. So this does not add up. I do not get the correct angle here, so I cannot say that these are similar triangles. Alright, let's practice some proofs. So first one is to prove that these triangles are similar. I have parallel lines. So there's a few different ways that we can go about this. Totally up to you. You could use vertical angles here, but I think that would be it doesn't really matter. So I see that angles A and P are going to be congruent by alternate interior angles, and then angles C and M are also going to be congruent by alternate interior angles. You could use that. So the way that I'm going to write my statement is that MP is parallel to AC, because that's given. And next, angle A is congruent to angle P by alternate interior angles. Similarly, angle C is congruent to angle M by alternate interior angles. And again, you could say here that angle CBA is congruent to angle MBP. It doesn't really matter. You could use those vertical angles if you wanted to. But because I only need two, now I can conclude that triangle ABC is similar to triangle PMB by angle. Okay, then they ask if we're only given that CA, so CA is to, let's try that again, that CA is to PM as CB is to MP, then could I prove that these triangles are similar? So meaning that I did not know that these two lines were parallel. Well, the only extra piece of information I would have is that these two angles here are congruent because of vertical angles, but this would be side-side angle, right? So I can't use that. It would need to be this angle right here. So angle C and angle M would need to be my congruent angles, but because they didn't give me anything verifying that, I cannot say that these triangles are similar. Move on. So next proof, I have a parallelogram ABCD. I need to prove that BFE is similar to CFD. Similar to CFD. Alright. So I have parallel lines because of my parallelogram. And so right off the bat, I can say that angles C and B are congruent, and I could say that D and E are also congruent. I can also say that CFD and EFB are congruent by vertical angles. Okay, so I see that I have the two angles necessary right from there. So with my statements, I'm first going to start with parallelogram ABCD. I'm going to say that CD is parallel to EA. This is a property. Actually, let's say this is a definition. That's true. So this is the definition of a parallelogram. as two sets of parallel lines. Okay, so third, let's use alternate interior angles. So I can say that angle C is congruent to angle B. I can say that angle E is congruent to angle D. Both of these by alternate interior angles. And so because I only need two, I can go ahead and skip to my conclusion. So BFE is similar to triangle CFD by AA. Okay, so they're giving us a little bit of different information this time. They are stating that I have two sides in proportion, essentially, and they're asking me to prove that these two triangles are similar. So via the picture, I can ascertain that my angles are vertical here. I know that PR and NP are corresponding, and I know that MP and PQ are also in ratio. So let's do a paragraph proof this time. Let's write the given. So PR is equal to 2NP and PQ is equal to 2MP. Then I know that my angle here, so I can say angle MPN is congruent to angle QPR by vertical angles. Okay, so from here I can write a proportion. So I can say by the given, I know that PR is to NP as PQ is to MP. Okay. This could be by the cross product property. I mean, essentially we just set them equal to each other, but I'll say by the cross product property. Okay, so then we can use side angle sides, so therefore by SAS I can say that my triangles NPM are similar to triangle RPQ. Okay, last few examples for these notes. First, we want to solve for x if the triangles are similar, and they're going to be similar, so essentially we're just asked to solve for x using ratios. So here I need to know my total length, which is 12. Okay, so I know that 9 is to 12 as 5 is to x. We can cross multiply. So 9x is equal to 60, so x must be 60 over 9. You could reduce that to 20 over 3 if you want. Okay, moving on. So again, I have a triangle within a triangle. I need to know this total length, which is 10 plus x. Okay, so I know that 10 is to 10 plus x as 8 is to 12. Okay, we cross multiply. So I get 80 plus 8x is equal to 120. 8x is equal to 40, so x is 5. Okay, now let's do some fact checking. So we have two classmates who found the value of x for the figure to the right here. Okay, so what I see from this is that x relates to 8. I see that 4 relates to 6, and then I see that 9 relates to 6 over here. Okay, so first they said that 4 is to 8 as 8 is to x. 4 is to 8 as 8 is to x. So they used this 8 here twice. They ended up cross multiplying and getting 8 times 8 is 72, which is incorrect. The 8's wrong, and x equals 18. So obviously A is not correct. Let's check B. So they say that 8 is to x, as 4 is to 6. So that looks fine to me. They cross multiply. 4x is equal to 48. Divide to get 12. So that looks great. Okay, this is not your homework right here. Your homework is on Classroom. Let me know if you have any questions. Otherwise, have a fantastic rest of your day.